Alright, welcome to some new slides. This is luckily not a hard topic. I'm going to talk today about files, how to write to them, how to read from them. It is nice and simple. It's so much better than the things we've been learning. I put this here for a reason, right? For a breath of fresh air after a bunch of hard topics. So let's learn about files. In C++, they like to use the word stream to talk about files, and that's their little metaphor. Like, think of a file as a stream of information, like a river of text, a river of data, ones and zeros that you could grab stuff from, like take stuff out of the stream, and then you can push stuff into the stream and have it flow down into a file. All right, so that's kind of their metaphor. You'll see that word a lot. But yeah, let's first learn how to write to files. It's going to involve a new type. It's called OF stream, so stream is everywhere. All right, this is actually, writing a file is another way of producing output, isn't it? It's we only have one way right now, don't we? We only have one way of showing the user something right now if we want to give them information back to them. All we have been doing is couting. That's wild, isn't it? That's true. Cout 42, that's the one way we can show the user something and tell them information. We can output to their terminal screen. This gives us another option. OF streams give us a way to give them information while the program isn't running. It'll write to a file. So OF stream is short for output file stream. All right, and it's just a type that like you can initialize with a file name, and it'll go and write to a file if you give it stuff. And it lives in a library called fstream. All right, so let's go there. So here is the C library. I would like input output and fstream at the top. All right, so there's a bunch of different things. There's an IF stream, of course. We'll talk about that. But OF stream outputs to files. All right, and this little diagram with arrows right there that you can't really see when I make it black and when I make it like dark background, that's going to become important soon. But this is easier on my eyes right now. So here's all the things that you can do with an OF stream. You can have it open a file, and then you can shove stuff into it. That operator exists. That's pretty cool. So yeah, there's plenty of examples. I don't know, let's click on this one. You scroll down, it's like, all right, make a file, and it's using cout as an output example. That's funny. Let's click on open. Okay, here it makes a file, opens it up, and then gives it stuff. That's essentially how you'll be using OF streams. All right, so here it works in the same way as cout. It's like it's like a file instead. So OF stream, this is how you like do this. All right, OF stream. I'll call it OFS, give it a name, make it an OFStream object, hook up the file somehow with like a .open call, and then you can suddenly start giving it information. And just as easily as you could have given 42 to cout, you can give it to your file, and then that line will write it to the file. All right. So yeah, OFStream stands for output file stream, and it takes that same operator, which makes sense. That's nice of the library implementers to do it for that, do it for us that way. Okay. So let's have our first example be writing 1 to 10 to a file this time. So I want to produce a file called like 1 to 10.txt, and I want it to have printed in there 1, 2, 3 all the way to 10. That's the file I like to make right now. Okay, so to do that, we have to make an OF stream object, and that's after including fstream. Okay, so let's make a new program that's going to, when we run it, create a file and write to that file. So I'll call it 1 to 10.cpp, and yeah, so let's do fstream. Then I get output file stream OFS, and then now I can say this. I can make a file OF stream OFS, and then I can ask for it to open a file. All right, so you make an OF stream object, declare it, and you open the file that you want to write to. So you have options when you do it this way. You can say .open. You can say .open on your file, and then give your file name just as a string. It's happy, it'll take it. And there's some optional things that you can give after that, but we'll use the defaults right now. All right, so just one thing is all we really need right now. And that will open the file so that when we give it stuff, it'll go to that file. You could have also used the constructor to do that in one little swoop. So like the constructor for OF streams, you could have given it the file right there, and it would have immediately opened it for writing. Okay, so you do have options. You can either do it this way, OF stream OFS, and then OFS.open, give it the file name. This is the file I want to write to, text file. You could have either done it this way or this way. You could have said OF stream, OFS, and then give it the file just like this in the constructor. I'll call open for you essentially. So you have options. All right, so these two below are equivalent to the one above. Either one you want to do, up to you. All right, so I've declared it and opened the file, and so now if I give stuff to OFS, it will accept it and write it to the file. All right, so I just write to it, pretending like it's cout. It all works the same. So I'll say for int I equals 1, I less than equal to 10, I plus plus. Instead of cout I at any line, I can give it to OFS, give it to the file, print there. Okay, and yeah, that's pretty much it. It will do the thing, and I do want to teach you though the right way of writing files. There's a close method that closes your file object so that like other people on the operating system can have an opportunity to use it if they need to. It's always good practice to close the file as soon as you're done with it. So there's a close method. Even though the file will be closed once the OF stream goes out of scope, like at the end of main, even though that's the last thing we're doing right there, it's still good practice to just get in the habit of closing your files. So it's good practice to close the file as soon as you're done working on it. So it's just OFS, whatever its name was, .close. So that's us being good programmers. All right. So now, if I run this, notice that there's only this file 1to10.cpp in my directory. I can compile it into a file called an executable file called 1to10, and then when I run it, watch, no output to the terminal, but it made a file. Isn't that cool? So here, let's look at it. It's 1to10.txt, and it holds exactly what we expected to have. Isn't that great? I love it. So it's working perfectly. Okay. That worked. That did it. Okay, so yeah, it's always a good idea to close your file, even though it will be closed for you once the OF stream goes out of scope. It's just, you should always just get in the habit of doing it, because one day you'll use a library where it doesn't work like this. All right. So yeah, remember that the nearest scope, the end of the scope means this, like it's the nearest closing curly brace if your OF stream is a local variable, which it usually will be. So like, really, it's going to go away right here. It will close the file automatically there for you, but maybe you wanted to do some fancy stuff in between. You might as well close the file the second you know you're done with it. All right? So yeah, there's that. Let's keep on talking. So let me rerun this program. You might expect it to do one of two things, right? If I rerun this program, what is going to happen to the file? Take your bets. It just so happens that it stays exactly the same. It keeps on being overwritten when I rerun this program. It never changes. This file never changes. Okay? So that might not be what you want. All right? It's going to overwrite. By default, OF streams just replace their files with whatever you're giving it right now. Okay? A lot of the time, though, you want to make like a log of all your stuff. You want to keep on adding to the end of an existing file. So that's called appending, which kind of hopefully makes sense, has the word end in it somewhere. And in order to append to a file, instead of overwriting it every time, you open it in a different way. All right, so that's where the options for like either after the constructor or in the open method, it takes some opening modes, all right, an open mode. And one of those is append. It's called this iOS_base : app. That's the mode we want here. That's the append mode. It's a little disgusting, but that's what we want. The default mode is out, which means replace, output and replace. So that's this one, and then here's app, append. All output operations happen at the end of the file. Okay, so moral of the story, we just want to open our files like this if we want to append to them. ofs.open, or even in the constructor, ofs.open, and then give it, open your file name, and then you're going to open it in append mode. That's iOS_base : app. All right? It's like a constant that lives within there. And then you can start giving it stuff. You start giving it like OFS 11. That will add to the end. So like if your file already had 1 to 10 like ours did, by opening it in append mode, it will not overwrite it. When you add your 11, it will add it to the end. That's what we want. All right, so let's see. I better show that to you. So let's steal our old program, steal this one, boop, and I'll call it append.cpp. And so what do I want to do? I would like to open this file, not in normal mode, but in iOS base app mode, app for append. And instead of writing all this, let me just write 11, like I was doing. Okay, so just like that. And let me split screen with the file. There it is. Let's watch it work. So if I run it, I have to like go to this page again for it to like reload the file, but there it is. It's added the number 11. If I run this a few times, 1, 2, 3 times, it'll add 11 a few more times. See, appending to the end. That's very nice. That's useful. Okay, so yeah, now you have both ways, overwriting and then appending. Okay, that's outputting. And now I want to come back to just OF streams in general and talk about this diagram, because this diagram is important. Oh no, I want it to go, there it goes. This diagram with arrows is called an inheritance diagram. All right, it has to do with where types get stuff from smaller types, more original types. It's like, it's a family tree of types, essentially. And let me talk about that, because it's kind of useful. So I want to talk about the type of OF stream, even though it already is of type OF stream, and then also the type of cout. By the way, cout it has a type. It's declared somewhere. It's an object, and it's an O stream. That's its type. So cout's type is an O stream. That's what I mean when I say it is an O stream. So cout's type is an O stream, and so is OF stream. All right, that should make sense. Cout does have a type, and that lives in IOStream, right? Let's go there, confirm that. IOStream has cout, click on it. Its type is OStream. Bam. And here's, you click on OStream and see all the things you can do with OStreams. And it has another diagram that looks like this. All right, so we'll get there. But, okay. OStream is also an OStream, which is weird to say. So OFstream is also the name of a type. Here it is, OFstream, OFS. It's just a normal type. But I claim that OFstream, even though that's a type already, it's also an OStream. And I mean it inherits from it. All right, it's a more specific type. It's based on OStreams. All right, OFstream inherits from OStream. This is a very complicated topic in computer science, in object-oriented programming. There's a section of your textbook on this. There's a chapter on it. I encourage you to read it. I won't force you to read it in this class, though. It's more of a 41 topic. And so yeah, OFstream inherits from OStream, and it takes a lot of stuff from that. All right, OStream is the more basic type. It's what cout is, and the things that you can do to an OStream are the following. Here's everything an OStream has. You do all these things. You have a bunch of output kind of operators, and it has this output like cout, OFS, like the arrows to the left operator, insert output. That is where they both get it from. That's why cout and OFS, they both use this, because they're both OStreams. They take that quality from the OStream type. All right, if that makes sense. That's the secret. That's why you get to use it in both places. That's cout's type to begin with, and then OFstream inherits that from it. All right, that's kind of interesting. So yeah, because those types are so similar, cout and OFstream, they share that, like this parent type OStream, then they work the same. They get that operator less than that exists for both of them, and it works the same way because of that. It's like cout, you can use it. OFS, you can use it, or whatever your OFstream was called. Does that make sense? That's kind of neat. And because those types have one in common, like OFstream and cout, they all have OStream in common, then you can use them in a similar way. You can use them in a similar way. You can use them in the same spot. You can treat them both like an OStream. All right. Where I'm going with this is the following. I can now make a function, because I know this fact. I can make a function that takes an OStream, just some arbitrary OStream, and I can give it a file if I wanted to, because an OFstream is an OStream secretly. All right. And then I can use the output operator on that OStream that I was given, whatever one I was given, and it will write to a file if I give it a file, and it will write to the terminal screen if I give it cout. I want to make this function. Does that make sense? Like write 1 to 10, give me an OStream to write to. By reference though. It needs to be by reference so that you don't like copy cout. That would be weird. All right. So yeah, inside of this function, what I want to do is like OS is something that is an O stream. That's the thing I was given. I can use that operator on it, and like whatever I was given here is going to be output to. So I can call it with a file. It will write 1 to 10 to the file, or I can call it with cout. Does that make sense? Even though OFS is going to be an OF stream, I can treat it like an O stream because it's inheriting from that type. All right, that's very, very powerful, very, very cool. So that's what I want to do. All right, so let's make this function. So I'll make a new file, excuse me, called OStreams. All right, so I would like to make this function. Can I just copy this? That would be useful. That one exactly. Takes an OStream. Could have been a file though. Takes an OStream, writes 1 to 10 to it, and so here let me steal. I am lazy. I will steal that code. But it's writing to whatever OStream was, whatever OS was. Does that make sense? Writing 1 to 10 to whatever OS was, and I can call it in a couple different ways now. I can call it with a file. So I need to make the file, of course. I can call it with a file. I can say, all right, write 1 to 10 to the file. And I'm allowed to do that. Even though in OF stream, its type is not OStream, it's inheriting from that type. So I can treat it like its parent type. All right. So there's that. And just as easily, I can call this function on cout. Does that make sense? And then I should always remember to close my OF stream, ofs.close. When I'm done with it. I guess I should put it right here. Huh. That would make the most sense, because that's when I'm done with the file, done working on the file. That's the soonest possible. And now watch. Can you kind of see what's about to happen? When I run this program, what's it going to do? Boop. It's both going to write 1 to 10 to the file, which we can confirm by going back to it and seeing that the 11s are gone now. It overrode it. Interesting. And then also it writes 1 to 10 to cout because I'm passing cout, and OS gets to be cout here. And so it's outputting 1 to 10 to the terminal screen. That is wild. That is so cool. I hope you agree. All right. So that's inheritance of types. That's where this this diagram comes from. OStream inherits from other things too, from iOS, from iOS base. What are those things? You can go look at them. See what they have to offer. All right. But here's OFstream at the edge of the hierarchy. All right. Back to black and white. So okay, I think that's what I wanted to say about this example. So that's as much as I want to tell you about writing files for now. Let's now talk about, you have a file already. I want to read from it, all right? So there's a way to like redirect it to like cin. We've done that already with like the less than operator. That's a thing. But like there's OFstream implies the existence of IFstream. So that's where we need to go next, all right? IFstream stands for input file stream, as you would expect. And this is, just like OFstream is another way to produce output, IFstream is another way to get input. So we've been able to get input using, we've had multiple options for that already. Like we could use cin and getLine with cin to get stuff from the user's keyboard as the program is going. We can also get stuff from the user before the program starts with the command line arguments, right? The argc and the argv. That's before they press enter, before the program takes over. So that's another way to get input. And here's a third way. Now we have an IFstream that we can read from a file, and you better believe that IFstream inherits from iStream, and that's the type of cin, and that's why they share, inherited from iStream, that's why they share this operator. You see it? It's all coming together. I hope you get it. All right. So yeah, that's your third option. It works very similar to these things. Like IFstreams are iStreams, and that's the type of cin, and that's where you get this extraction operator from. All right. Cool. So now you know. So like cin is an iStream, and so is an IFstream. All right, that's a correct word. So let's make a program that does this then. Let's read the first 5 integers from a file. We'll open up a file and then read ints from it in a way that looks very similar to using cin. and it'll work out. So as long as the numbers are white space separated, just like seeing input from the user's keyboard works, we'll get it. All right, it'll work in the same way that you expect it to work. So let's get those numbers and do something with them. Let's like sum them up. Okay, so I'm going to make an IF stream to read from the file, and you can always click the constructor, click the open to see an example of how it's being used. All right, so it's trying to get a single character at a time in that example. What about open? Does it do anything different? No, same example. Never mind. I'll show you my example. It looks very similar to see it. All right, so here we've got a file, right? We got this one. Let's read from this file and go from there. So here, I'll copy most of this. What do I want to call this? I guess I'll call it ifstreams.cpp. And so instead of that, instead of making an OF stream and doing stuff and closing it, let's make an IF stream and call it IFS. Yeah. Open it, close it when we're done. It's still that's still important. All right. So we've got the file. It's open for input, for getting stuff out of it. Let's read all the numbers. Let's read the first 5 numbers. So int and sum them up. Int sum equals 0, and then I'll loop through. I'll just loop 5 times. That's all I really need a loop to do. I want to read 5 numbers. So I'll loop 5 times and get a number. Next num. And just like if the user was typing, I could use cn into next num. Pretend that the file is like that. I can just read from the next thing in the file, the next int in the file, into that number. All right, and add it into the sum. All right, sum equals, next num. Bam. And then we're done. We want to output the sum. Does that make sense? I am, though. When am I done with this file? When can I close it? This line, I'm already done with the file by that line, so it should go above that, shouldn't it? Like, I do need the file in here, because I'm reading from it on this line. But the second that loop is over, I've used the file for everything I need to use it for. That's where I can close it. That's where I notice I don't need it anymore. So, all right, it's going to read the first 5 white space separated things, so it's going to read the numbers 1 through 5 in this file. And then sum them up and show us the output. And apparently the sum of 1 through 5 is 15, which makes sense. 9, 10, 15. Cool. All right, so that's that example. But what if, like, you didn't know how big the file was? Like, we were lucky. We made this file ourselves. We knew it had at least 10 things in it, so we can get for sure 5. What if we didn't know, though? How do we loop until the file is over? All right. So if you want to read from any arbitrary iStream, including cn, you can do it in a loop, all right, and figure out when it's done, all right, because that's what we want. It'd be nice to read the whole contents of a file, and like, how do we know when it's over, though? How do we know when the file is done with and I can stop reading now? Well, it just so happens that every iStream knows if it can be read from or not. It knows when it's over, okay? And an easy way to check is to have it be implicitly converted to a Boolean value. So you're allowed, every iStream knows how to convert it to a bool, how to convert itself to a bool. And so that means you can use it in a condition. You can be like, if IFS, do something. And IFS, your input file, gives back true whenever the file is like good, whenever it's okay to be read from, if that makes sense. All right, so keep giving back true, and you can run the body of your if or your while as long as it has something. It'll tell you, like, it's good, I'm still good, run the body, I've got something for you, all right? IF streams, they stop being true, they stop giving back true once you hit the end of the file, okay? That's one reason, that's the most common reason, all right? So that means we can read from IFS in a loop. There's also another, you have options here. You could instead there's a .eof method on IFS. It's like .eof. EOF stands for end of file, and it returns back a Boolean, true if your file, like if your stream has hit the end of the file, and false if it hasn't yet. Okay, so you can also use that one, but yeah, it'll give back true or false if you hit the end of the file. But I like this way, honestly. It's more general, and that means you can do something weird like this. You can use this as your condition of a loop. All right. So if you put this syntax, what it's going to do is it will read, it'll try to read into whatever your variable s was, it'll read, and then it will evaluate into IFS itself, as if you had just said this, all right? And if you put this then in a loop condition, it will keep giving back true or false depending on whether your read succeeded or not. That's pretty cool. So you've done this already. I've told you how to do this with Cn in a lab, but this is kind of why it works, all right? So the moral of this story is you can do this, and you can read one thing at a time into your variable from IFS, one at a time, and this will result, this line right here, this will result in true as long as that read was successful, and it'll keep running the body when that's true. The second it becomes false, your file's over, and it won't run the body because the read failed anyway. That's exactly what we want. This syntax will run the body every time you get a valid value, and you can mess with it and use it in the body each time. Isn't that cool? I love it. So with that in mind, here's an example. Let's sum up every number in a file, all right, until it's over. And then I'll show you how .eof is going to show you that it's true as well, okay? There is an ordering issue there, though. If you do use EOF, you do have to try to notice the end of the file. You have to like have a read fail once. I'll get into that eventually. So what's this example? What do I want to call it? Let's call it sumeverything.cpp. So here, I want files. Oops. And can I steal this? Kind of want to. Here, let me steal this. Most of it, because again, I want to open this file. Again, I want to sum stuff, but instead of doing a for loop, I would like to do the following. All right, I'd like to say while, and also make a number to read into each time. Nextnum. I want to say while I can read from IFS into nextnum and actually get a number, and it worked. It gives back true. Run the body. All right, so this syntax is saying the body only gets run if the read worked. If the read was successful. All right, that's the goal. And I think, does success have two C's? I can't remember. Something like that. Okay, so yeah, I think that's what I wanted to say there. And so what do I want to do with each number as I get it? I'm guaranteed that the number was a valid number, like it still worked. There was still a number left in the file. It's called nextnum. What do I want to do with each nextnum I find? I want to add it into the sum. Just like that. And so the rest of the program stays the same. This will read every single number in the file, if it's just a file of white space separated numbers. That's kind of cool. And so what was my file? It was 1 through 10, right? That's what was in this file. Just 1 through 10. And so when I run it, it gets the sum of 1 through 10, all the numbers that were there, no more, no less. And it holds 55. If I added another number, saved it, I don't even need to recompile because it's just going to read the new version of the file. Now it's 66. Cool. All right, I think that is what I wanted to show you for that example. That's how you can read everything. I should also show you that EOF, the second this while loop is false, right? The second this becomes false, it means the read failed, which means it found the end of the file. So ifs.eof, like, am I at the end of the file or not? It should give back true here. And remember that bools will be printed by default in C++ as 1 or 0. So we're going to see 1 printed for true. It is at the end of the file. Okay? So there it is. All right. So with that, yeah, I think that's most of what I want to show you. Got one more example. And this is something I want you to try. I want you to try this first. It's a very good exercise to just make sure you're understanding everything. So here's the program I'd like you to try, please. Please write a program that repeatedly gets a line from the user with getLine and appends that line to a file. It's like a little message board, just on your local machine, though. It's like people can leave little notes for you if they run this program. It will append their notes to the end of the file. All right, so for example, you have like a file name that starts out potentially empty, and if it doesn't exist yet, and then what I want your program to do is something like this, like give them a prompt, ask them for lines, and like the user starts typing stuff. Like they type hi, hit enter, it writes hi to the file. They type mom, hit enter, it writes mom to the file. They type blah, hit enter, it writes blah to the file. Do you get it? And then to eventually stop, let's say that Q means quit, and so Q will stop that program. And so that's one version of the program. It should write that to the file. But it should append so that if you rerun this program, this little chatbot message program, and they start giving you new notes to put into the file, like they say hello next, that should add to the end. And if they said Q after that, that's it. Does that make sense? So you're going to append to a file, iOS space : app mode is what you need to open it as. And so here's that example of, appending. I'll give it to you right here. Boop. And I guess remember the F stream here. I'll give you all this. Bam. Stare at that as you're trying it. All right. So make a little app that lets you leave a note for somebody, and it starts saving all your notes to a file. Okay. So give that a try, and then I'll show you how I think about it. All right. I promise it's worth trying. Before I show you the answer, you learn more when you do it yourself. So here, let's make a new file, getLine and append, and fstream, of course. I would like to write to a file called something. I don't know what I want to call it. I need to make an OS stream though, because I'm writing. And let's open it using the constructor this time. Maybe I'll output to a file called out.txt. And I want to output with append mode. iOS space app. App. Right? So there it is. And eventually I want to close it, right? Oh, sorry. I want to call it something, stream OFS. There I am running the constructor. And close it when I'm done. And then in between, how do I want to use this? I just until the end of time, until the user types Q, I want to ask them to enter stuff. So string line, I guess I need a string variable, huh? And the getLine function. So string line, cout, enter line, getLine from cin into that line variable, and then just as long as it wasn't Q, shove that line into the file itself. All right, so if the line was Q, then I'm done. That was the entire contents of the line break. Otherwise, if we're still here, it was a good line. It wasn't Q. I want to add this line to the file, and the file's name is OFS. So it doesn't have to be called OFS, by the way. I just that's my go-to example. It could have been called file, F1, whatever you want to call it, just a variable name. So here, add the line to the file by saying this, OFS, give it the line, and then getLine gets rid of the new line. It takes up until the new line, so you have to add it back in if you want to break that line again. So there it is, and then we close it when we're done, and that's the relevant code. It'll work. So here, let's run it. Let's say G++ first, of course. Boop, enter line. Hi, mom, blah, Q. All right, and what that has done is it's made this file, out.txt, that holds hi, mom, and blah. Okay, so there's that. An easy way to print the file, print the contents of a file to the terminal screen, you say cat. Cat is short for concatenate. Print out the contents of this file. That's another way to show it to you. So if I rerun this now, if I say hello and Q, it should have rewritten to the end of this file. And there it goes. Cat would have shown it to you as well. So yeah, that's a fun little example. I hope you see it, the usefulness of it, and this kind of program is alive and well inside of pretty much every computer, because every computer has logs of people who signed on to your server, etc., stuff like that. So it's just a program that's keeping track of who's logged in and writing their names and the time to a file somewhere. That's the backbone of generating data in a lot of places. All right, so it's a very useful program. Now you know how to write it too. So I think that is where I want to stop for the day, at least for the main lecture. So yeah, that is all that I have to say for now.